Hello, welcome back. Today we're going to be taking a look at a very important formula for us, what we call the second fundamental theorem of calculus. Now we're going to be spending a lot of time with this one, so get cozy. Before we start, let's start off by taking this antiderivative here. This is our FTC, so of course our rule just says if I integrate this with respect to t, we would get t cubed over 3, and we would evaluate that from 1 to x. Applying our FTC here, of course, we're going to get the f of x here minus f of 1. Plugging in the x, this just becomes x cubed over 3 minus 1/3. That should be over 3 there too. And there's our antiderivative. There's our FTC, and so this is going to be like a little area problem right here. So today we want to say, well, what would be the derivative of the answer above? So if we take the derivative of this now with respect to x, notice we're changing our variable from t to x. So I want to take the derivative with respect to x. And I'm going to rewrite out my integral, my answer here. And if we take the derivative here with respect to x, it's x cubed over 3. That's just going to give us x squared minus, and of course that's a constant, we get 0. And therefore, if you notice, we get x squared. So the next question asks us, what do we notice? Well, the first thing I noticed, I took the antiderivative, and then I took the derivative. And anytime I do an inverse of a function, like if I, for example, I take the square, if I take the square root of x and I square it, since these are inverses, we should just get our x back right here. And that's exactly what happened. Notice we got this x squared, but inside my antiderivative we had this t squared. They're really exactly the same. We just replaced our our t with x. So we notice this is the same as what is in the integral. And that's really kind of big for us. This is what we call the second fundamental theorem. Throughout the year, we have learned to take the derivative. So what's going on here? Throughout the year, we have learned to take the derivative using various techniques, such as product rule, implicit, exponentials, and so on. Today, we're going to learn how to take the derivative of an integral or an antiderivative. We actually have a very special way to write that. We say it's the derivative of an integral from a to b f of x dx. And we're going to try to find out what this gives us, and later on we're going to take a look at what this tells us about a graph. So let's take a look at what we call the second fundamental theorem of calculus. Whoops, there's a mistake here. These should be t's, not x's. Although in the AP they'll be like, oh look, they misspelled the letter t. All right, so let's anticipate what's going to happen here. So this says I want to take the derivative of an integral. Now if we think about above here, remember how we had this, we got t squared, and then we got this x cubed over 3 minus 1/3, but then we took that derivative. We got x cubed, and we took the derivative and we got x squared. We got the same thing back from the antiderivative. So what should we expect to be our answer here? Again, I'm taking the derivative of an antiderivative. So yeah, if we look at what we did above, all we did was we replaced the t with this x. So I think I should get, well, it's not t this time, x cubed. Now if you notice, there's going to be no plus c on these because we're taking a derivative. That derivative of that constant just became 0 right there. So let's see if our anticipation works. So what we're going to do is an order of operations. If I look here on the inside, I can take that antiderivative, and that's going to give me t to the 4th over 4 evaluated from 1 to x. If we use the FTC, f of x minus f of 1, we would get x to the 4th over 4 minus 1/4. And if we now take the derivative of that with respect to x, we do get x cubed. If I bring down my power, we get 4x cubed over 4. They cancel. And that's a constant. That just becomes 0. So indeed, we do get our x cubed. Well, what do we suppose we should get for question 2 here? Yeah, we should get sine of x. So let's kind of see what's happening. If we use the first FTC, the first FTC says, I am going to find f of x minus f of 1. The second fundamental theorem simply says, now take the derivative of that with respect to x. So we get f of x minus f of 1. Well, if I take the derivative, this is just going to give me f prime of x minus, well, this is just a constant, so therefore that's 0. So we're left with just f prime of x, which you may recall from an earlier video that this in part in here is my derivative, f prime of x. That is my f prime of x. So what's that going to give me? Just exactly what I got back. Sine of x. I just replaced my t's with x's. Very easy to do. So we have a rule. Let's see if we can come up with a rule for this. If we take the derivative of an integral, all we're doing is we're going to replace each t with x. So this should just become f of x. Now, what happens to the dt? Well, it's really, we'll talk more about that a little bit later on right there. So we should just get f of x. And this is our rule for today. This is what we call the second FTC. So let's try a slightly more challenging one. Notice this is the exact same as the first one, except for now our domain, notice our domain is this x cubed. So when I set this one up, I'm going to do the same technique I did up here for question number 2. I'm going to use the first FTC. And that's going to be f of x squared minus f of 1. Now, my second FTC says take the derivative of that. Now, you got to be really careful here. If I take the derivative, we get f prime of x squared. There's a chain rule times 2x minus, and again, this just is a constant. It just becomes 0. So what's my final answer going to be? Well, remember, this t squared is my derivative. So in place of t, I'm just going to replace that with x squared. It's just a substitution. So this becomes x squared squared times 2x. And if you clean all of that up, we get 2x to the 5th. So let's try number 5. Now be careful, this is not the fundamental theorem. We're not integrating, we're taking the derivative of an integral. So our rule said if we take the derivative of an integral, we should just get our derivative back. We should just get the inside back. In other words, these two things, they just cancel each other out. The derivative and the antiderivative just cancel each other out. So to do this one, I'm going to use my FTC, f of x cubed minus f of negative 1. And next, all I'm going to do is just take the derivative of that, like so. And if we take that derivative, let's see what we get. We get f prime of x cubed. Be careful, there's a chain rule, 3x squared. And again, that's a constant, so its derivative is 0. And now my final answer, I'm going to replace. There's my f prime of x. We're going to replace each t with x cubed. So we get x cubed to the negative 3 times 3x squared. And you should clean this up. That becomes x to the, what's that, negative 9 times 3x squared. Add it, we get 3x to the negative 7. And there's our answer. So what could be our shortcut here? For our shortcut here, well, again, we're just going to replace each t with x squared. So we're going to get f of x squared, now be careful, times, and then we're going to do a chain rule. So you see this dt right here? This dt is really a chain rule right there. So we're going to take the derivative of x squared. I don't have to worry about the a. A is a constant. And its derivative just becomes 0. We saw that up here. So when I simplify this, we're just going to get f of x squared times the derivative, which is 2x. And that would be our rule. All right, go on to video number 2, and we'll take a look at some more examples. See you then.